Hello, everybody. Welcome to Projects Day. We're starting off with the best team. We are team CS 2311. We're working with Mary's Place this year, and we'd love to show you around what we've built. Excellent. Let's start off by meeting the team.
Application and resizing everything, like the calendar fit, so it looks correct.
Yeah, that's a great question. We mainly focused on the application, mainly Android, because the majority of the users are going to be Android users. But we did make it so that it can do the web application, but it wasn't our priority. So maybe some of the, I don't know, it might not be the best port per se for the web version, but it's all fully functional. But that is hopefully something that the next team can take over and further develop.
Yeah, kind of a similar question, thinking about the difference of web versus mobile, with the newsletter PDF viewer. And this is probably more on their end than yours, but are they writing those PDFs, designing them primarily thinking of people on like a desktop viewing them? And does that, have they had to rethink how they design those in light of now there's this new smaller screen version that people will be using?
It seems like it should all be the same.
Okay,
the PDF viewer, yeah, it just adjusts the size automatically, the PDF viewer. But yeah, we mainly tested on the Android application though.
I just wanted to ask them. So is that so the viewer's embedded? That's why it wasn't like a download. It was like the moment you clicked on it, it was if you were on a website, right?
Yes.
Okay. What was that program?
Let's see. Well, we used Firebase for storing all of that, so we just go fetch the information directly from Firebase and upload it on the app. So when there is a new Mockingbird times, then it gets uploaded to the server, and then when you connect to the internet with the app, then it automatically updates it to the new one.
Was there a reason that you didn't allow access to back issues of the newsletter? Maybe there was something came out a couple of weeks ago.
Yeah, so that was actually part of our that was something we were going to develop later in the project, but we weren't able to get to. So hopefully that's something that the next team can finish up for us. Any other questions?
I have one more question. Do you guys see a problem with resizing the calendar? Because that seems like it's a lot of like, if you guys haven't got it resized, it seems like a lot of like difficulties maybe with the mobile.
Personally, we haven't gotten into that. We were primarily working on just like use. So for the mobile app, there's no problem with resizing, but we did notice that with the web page that once you like make the page smaller, there's like overloads the page.
Yeah.
But we weren't able to get to that for the project this year. Okay, yeah, so maybe
Somebody's computer again. So
Okay, but hopefully the next team can do that. Yeah. Oh, it's technical.
Yeah.
The last presentation for discussion was to 2213.
okay.
We have the process for the fix with the virus life protection.
Oh,
Having layout
Fantastic.
Cool, we'll get started. Hi, everyone, we are team 23.13 and we're working with Panthera. So for a quick team introduction, my name is Cost-Virtualizing and I am in charge of architecture and DevOps for the quarter.
My name is Kevin Collin. I am the team coordinator. I'm Julian Stefanczyk and I'm the client liaison this quarter.
And I'm Mia Rogers, and I'm the tech lead this quarter.
Yes, and in addition, we have working with us our team advisor, Dr. Shadbak Samavi, and our project sponsor, Thabib Mahal. So quick backstory on what Panthera actually is. Our sponsor company, Panthera, was founded in 2006, and it's the only organization in the world that is devoted exclusively to the conservation of the world's 40 wildcat species and their inhabitants. Panthera is a diverse team of wildcat advocates, biologists, data scientists, and law enforcement experts who all work together to protect and study the seven species of big cats. They also come up with targeted conservation strategies for the world's most overlooked and threatened small cats as well. So as for their core values, Panthera's core values are to protect wildcats, their prey, and their habitats, to combat the illegal wildlife trade, to help people live peacefully alongside wildcats, and to ensure that wildcats are able to roam freely. In 2017, Panthera created what they call the Panthera Integrated Data System, or Panthera IDS, which is a very powerful data management and analytic tool, but used by conservationists in the field. So essentially, there are camera traps placed all around the world that use motion detection technology to automatically take pictures of any movement that walks by. So typically, sometimes it's like a leaf, but other cases, more often than not, it's like an animal. Those images are then taken from those cameras and manually fed into Panthera IDS, which uses machine learning models to classify the animals by either species or by specific individual. So for example, if there's two panthers, it'll tell like by the stripes or by the size which panther is which. The issue here is that the platform doesn't really run as smoothly as it should when used in the field and when dealing with a lot of data. This is especially the case in the field because a lot of the times when Panthera IDS is run, it's run on either a phone or a simple laptop, which has low RAM. So when dealing with a significant amount of data, the platform runs fairly slowly and insufficiently, and that's what we're here to fix. With this issue, our team had the opportunity to identify and develop new methods of pre-processing to optimize the image classification model for the system and the limited computational resources. We aim to find a way to increase efficiency without sacrificing the accuracy of the model. We also ran tests that determined the optimal number of images to test at once for a given area, all in the hopes that conservationists, when using it in the field, won't be bogged down by the limited computational resources. So our goals for the project, our vision was to optimize Panthera IDS so that users everywhere can classify images quickly, efficiently, and what did that say? Accurately. There we go. We explored different models within the platform to streamline the experience for all the users. And again, we wanted to enhance the accuracy and lower the performance costs for use within the field without sacrificing efficiency. As for our mission, we were continuously looking to identify areas where Panthera IDS was either lacking or where users were consistently running into issues. Again, we wanted a smooth experience for everyone that was using it with low RAM. And as for our goals, our goal was to make the platform maintainable and robust for use within the field. Our minimum viable product was a smaller scale clone of the current model, which we replicated with generic off-the-shelf convolutional neural networks. A stretch goal we had was to explore various image pre-processing techniques to make the thing run faster. The primary one being image cropping. As a deliverable, we want to deliver a decision matrix which compared the convolutional neural networks that we worked with. So now I'm going to pass it on to Mia to discuss the project architecture.
Great, thanks, Costello. So this is our project architecture that shows our workflow for our project over this 9 months. So we were lucky enough to be able to use the CSP server from the CLU computing lab. So we stored all of our images on the server,
which we then used to split into training data, validation data, and testing data, so that we could evaluate the performance of our models. We then ran various image pre-processing scripts on the images before we classified the images, and in the classification step, we utilized the server's 2 GPUs, which sped up our model training time very significantly. And then after that, we are able to analyze how our models performed using performance data such as the model history. So Panthera provided us with a data set with around 31,000 images that comes from one of their North America sites. And then this data set contains images from 64 different motion detecting cameras and contains 21 different species. So now I'll talk a little bit about the tools and technologies we used. We used Visual Studio Code as our integrated development environment and GitHub to share our code. Our sponsors already use Python for their image classification scripts, so we continue to use Python. For our image pre-processing, we used OpenCV, which is a widely used computer vision library. And for our image classification, we use Keras and TensorFlow, which are deep learning libraries that are commonly used for Python developers. And finally, we used Pandas for our data management. So as we mentioned, we are using convolutional neural networks, or CNNs. And this is a type of deep learning model that is especially used in image classification. So essentially we give it an image and it'll tell us what animal species is in the image. And since convolutional neural networks take a lot of computational resources and time, we decided to use transfer learning, which basically we're using pre-trained weights from another model that's been already trained to classify images, and then we modify it slightly to be able to predict our own classes. And finally, with this large data set, we were having trouble loading in multiple images or a large amount of images at a time. So we ended up doing batch processing, where we loaded in only 32 images at once. So this allowed us to run the models without our computers crashing.
Sorry to interrupt. Our Zoom people can't see the thing, so I think you need to share the view that we can see it.
Okay. All right, so now I'll hand it off to Kevin to talk about some of the specific models that we use.
Right, so this is the decision matrix for our models. On the left here, we can see all the 4 models that we chose to use, which is the DenseNet, the VGG, the MobileNet, and the ResNet. And basically what we're doing here is we're measuring the 2 most important metrics that we want to measure, which is computational efficiency and accuracy. So the computational efficiency can be measured by the CPU inference time per step, the GPU inference time per step, and the accuracy can be measured by the 2 top 1 and top 5 accuracies. And basically, the difference between the models is basically just how efficient are they and how accurate they are, right? So the DenseNet is probably our most computationally expensive, but it is also the most accurate. VGG and ResNet is kind of like our 2 mid-range models, and the MobileNet is our cheapest model. And so here we have the milestones that we've been working towards this project. So first off, we have the model architecture setup, and this is basically the bare bones architecture of the models. So that's like setting up the convolutional layers that Mia was talking about earlier. And this step also includes a lot of the data cleaning, so like data pre-processing, data cleaning, and the data analysis. The second milestone is image processing and model fine-tuning. this is kind of the main step that we've been working towards, because this is where we actually see the improvement from the base model itself. So, which Julian will talk about the image processing scripts later. But basically the model fine tuning is basically just tuning hyperparameters such as like the number of epochs, the input shape, the activation functions, among a lot of other different hyperparameters. And the last kind of milestone that we have is the automatic image cropping. So you'll see Mia walk through this later, but it basically crops to an animal, and it does it automatically. Yeah. So we have three main blockers. The first one being computational limitations. So like Mia said earlier, it is very difficult to run neural networks, especially if you have like 30,000 images. So basically we've been running it on the server with the two GPUs and 100 gigs of RAM. And yeah, and so that helps speed up the process. And the second blocker that we have is the class imbalance. So Panthera actually handed us a data set that was pretty skewed. So what that means is, say like half of the photos that they give us was photos that were classified as either like a black bear or a Colombian black-tailed deer. And while the other 20 classes don't show up nearly as much as those two. And so basically what that does is it biases the machine learning model. So that was one of the problems that we had to work to fix. And our last problem is the memory constraints. And this is the biggest one because we were having difficulties running the models and training it because of these memory constraints, which we kind of fixed after moving everything onto the server. But some of the solutions that we worked towards were creating this image data generator, which fed in the images part by part. And we also made a garbage collector as a callback of one of the models. And we also decreased the batch size, which helps with the memory constraints. So I'll be passing it on to Julian to talk about image preprocessing.
Thank you, Kevin. I'm now going to be talking about the image processing techniques that we use. The first step for our image manipulation was taking the unfiltered photo and resizing it down to 224 by 224 pixels. This is done because TensorFlow requires an input size of 224 by 224 when using pre-trained models, which we were. After resizing the images, each image was then fed through all three of the image filtering processes that we went through and began the 3 different tests before moving on to machine learning. For our filters, we chose the Gaussian, the median, and the bilateral filtering processes. So I just wanted to explain what a kernel is. These image processing techniques use what is called a kernel or a convolution matrix to transform the images. The kernel acts as a weight between the unfiltered and the filtered images. For example, for a given target pixel, as you can see there, the one that's in the top left corner, it's in the middle one. For each target pixel, a 3 by 3 pixel block, it surrounds the target pixel, is used to compute the new value, which is found there on the bottom right. So the right would be the transformed image once we go through the image manipulation process. And so for the 3 by 3 block, each pixel is multiplied by the corresponding pixel in the kernel or the weight that's in the middle there. And all those products are added up together. And then that value is what the new value is for the final image transformation. So to talk about the 3 processes we chose, we first have the Gaussian blur. The Gaussian blur is a technique that blurs images using a Gaussian function as the kernel. It's typically used to reduce image noise and detail. Image noise is defined as a random variation of color, which can be produced by image sensors and camera circuitry, as well as certain lighting conditions. For a clear example, here's a picture of a bear that has a lot of noise. A Gaussian blur reduces the image's noise by removing high-frequency content, also known as a low-pass filter. The filter uses a Gaussian function for the kernel, which goes through the pixels one by one and changes the target pixel based on the surrounding pixel area. Pixels that are closer to the target have a greater influence on the final pixels value, whereas pixels that are further away have less of an effect on changing that value. Another example, you can see how the Gaussian blur works. On the left here, we have the unfiltered image values for each pixel. So the target pixel in this example would be 25, the green one that's in the middle of the 3x3. And the 3x3 block surrounding it is what we're going to also use to compute the final value. In the middle here, we have the kernel. So for example, the top to left pixel is going to be multiplied by what the top left value is of the kernel. 2 times 1 is 2. And then that happens for all 9 pixels. The values are added up, and our final product is 198 for how that pixel is going to be transformed using the Gaussian blur. And this process repeats for all pixels in a given image. Next, we have the median blur. The median blur is another image manipulation process that smooths noise, and it is widely used in image processing because it can preserve edges also while removing the noise. It functions by running each pixel and getting this 3x3 block, and new pixel in the filtered image is going to be the median value of those 9 pixels. You can see an example here. We have the 3x3 block once again in the top left corner. Those 9 pixels are sorted from min to max values, and the median value is computed here on the right. Funny enough, for this example, the median value did not change. So that's another thing that can happen with median blur. Finally, we have the bilateral filter. Bilateral filter is another smoothing filter with noise filtration and edge preservation. It blurs an image while retaining areas of high contrast. Bilateral blurring works by replacing the intensity of each pixel by a weighted average of intensity pixels from nearby values. The weights are applied, not only factoring in the distance between pixels, but also the intensity of color changes between pixels. And we here have once again a demonstration of how the bilateral filter in the middle is applied to a 3x3 block, which changes 10 to 4. I'm now going to pass it off to Mia to talk more about image cropping.
All right, thank you, Julian. So for an overview of the cropping, we used image masking and image subtraction. And to do this, we grouped the images by their timestamps so that we would have sequences of images that were taken within a few seconds of each other. So that means it would be the same animal. But there's 4 main steps. First is transforming the images. Then we created a mask. Then we found the area of interest, which is where the animal is in the image, and then finding the bounding boxes. So I have an example of what each of these steps really looks like. Okay, so here on the left, we can see our 2 original images, which show the puma. And then in the middle, we have the transformed images. So we did a Gaussian blur, and we equalized the intensities of the pixels so that the contrasts would be normalized and there won't be as many differences between the images in terms of lighting. And then we subtracted these 2 images to get the binary mask, which you can see here. So this is where the animal is in the picture. So from the binary mask, we are able to find our area of interest by finding the largest segment of white pixels in the mask. And from that, we're able to get our coordinates of the bounding box to get these cropped images. And as you can notice, they are squares. So when we convert it to 224 by 224, we're not distorting the aspect ratio of the images. We are maintaining a square, which hopefully should help the machine learning models. And then I have a couple more examples. So this is one of our original images. There's a coyote right over here. And this is our cropped image that we got. So the computer did this all on its own automatically. Here's another one. It's a little bit harder to see, but there's a bird right here. And this is our final image. And then lastly, this one's probably the hardest one. There's a snowshoe hare right here. And this is our final image. So now I'm going to pass it off to Julian to conclude the presentation.
Thank you, Mia. In conclusion, we found increases in classification accuracy for several of our image processing. So for DenseNet, the bilateral filter, offered an increase of accuracy over the unfiltered image. For VGG 16, the unfiltered images actually had the highest accuracy for our models, and MobileNet, both Gaussian and medium filters resulted in higher accuracy scores over the unfiltered images. And finally, for our ResNet model, all three of our filtration processes resulted in higher accuracy. It was very exciting. Overall, the most accurate prediction we saw came from ResNet with the Gaussian blur. And we learned that smaller batch size resulted in more efficient learning models. Moving on, hopefully for next year, if Panthera sponsors another project, there are plenty of other image and photo manipulation tools that can be explored. We hope that they also get an opportunity to explore different batch sizes as well as more stable amounts of animals in the data set. So hopefully the animals have a more even distribution is the word I'm looking for. Anyway, we just wanted to thank CLU for having the projects today and the projects that we did for the last year. Thank you to Panthera, our sponsor, as well as David Mahal for his work and helping us all throughout the year. And finally, our advisor, Dr. Samabi, who couldn't be here, unfortunately, but he's very proud of us, I promise you. I'd also thank you all for coming today and listening to the First Project Center. Thank you.
We'll now take questions.
So you have the 4 different models that you were looking at, you had accuracy rates for each of them. Did you look at whether those models were tending to be correct or incorrect on the same images as one another, or whether like one model would do well in certain situations and another would do well in other situations?
We're looking at like the overall accuracy, so we haven't really like focused down on like singular images, but we're like looking at the overall accuracy with these models. Yeah.
What causes the vastly different sizes between the models? One of them was 14 megabytes, one of them was 500.
So like a lot of the difference causes in like how many layers each has. The VGG model is kind of like the brute force model. That was probably the one that you were looking at. It had like 500 megabytes, I think. And this is probably because the VGG is like a brute force model. It has just like a bunch of layers, a bunch of parameters, and yeah. Whereas the other models, they kind of like try to use different techniques to keep the model size low, but still have a pretty accurate result. Yeah.
So a lot of these like pre-trained models are all trained on natural images. Did you look at which, like if there's a black bear in one particular training set for like ResNet or something, how that affected the accuracy?
We use the same data set for all of our tests. We didn't really narrow down on the specific images that it was getting correct or incorrect. We mostly just looked at the classes because we were saving our model history and our classification reports. So we didn't really have access to which specific images it was getting right or wrong.
So I just wanted to clarify, Adam's basic model, you guys were trying to translate a picture and then find the animal and then basically zoom in on it. And then later on, the next step would be that the AI would start picking it apart. Is that?
Yeah, so we didn't really have enough time to explain fully what a convolutional neural network does, but it basically extracts a bunch of features out of the images and it learns patterns in these different features it extracts for the different animals. So it basically just does a bunch of filters and crunches some numbers and then finds what the patterns are between the classes, and then that's how it's able to predict the class.
Registered for like.
As you can see. Yes. Are you guys gonna do present or just gonna do PowerPoint?
Just the thing, yeah.
Oh my God. Yeah, you sure that.
Oh, on the Zoom as well.
Yeah.
Which one is the Zoom?
Yeah.
You have the Zoom name?
Yes. Speech be ready.
This one. Oh, this one. It's on it. Yeah. Is that it? Oh, okay. Oh, this one?
Yeah, like.
It's okay, we got it. You're not changing it. It's okay, that's fine.
Plug him in there. This.
Yeah.
Oh, my, yeah. Oh.
All set here. Time to go check next. I'll pop my head in a few minutes to make sure everything's good. If anything does come up, this phone behind you is Parliament, no service.
But then, you know, that might be.
I can share. Oh. Yeah, you can see it.
This one is the one in town.
No, that's the this one. Not. Oh, this one. Is it on? What is on now?
Yeah, it's just projector.
Yeah. So you have it on the stick.
I mean, you have this all plugged in as you should. This was on VGA. It needed to be on VGA.
Oh,
Yeah.
Apologies for the delay, should be ready in just a moment.
Yeah, hello everyone, sorry for the delay. Thank you for coming to our presentation. We are Team CS 2316. Our project is Aftermarket and we are sponsored by the Fields Foundation. So let's meet the team. Our sponsors are Zach Self and Tori Kiriara. Our advisor is Professor Tim Spinney, and our team members include myself, Andrew Varela.
I'm Suresh Guru.
My name is Imran Islam.
I'm Alita Kim.
And so the Fields Foundation is a nonprofit organization that is committed to their model of being an accessible, low barrier community that amplifies emerging artists from traditionally overlooked backgrounds. And so they do this by developing projects and initiatives that at the intersection of art and community. And so next, Imran will present about our opportunity at hand.
Thank you, Andrew. So currently, the Fields Foundation has a website called Aftermarket. This is essentially an e-commerce platform that they're going to utilize to help artists get into selling their art online. The opportunity that we have through the CLU program is to create a mobile application that works with that existing website. This is a really exciting opportunity because the ease of use of smartphones is higher than it's ever been. With almost 7 billion people using smartphones, more people than ever are shopping from their smartphones. There's also increased accessibility, as many sellers will be on the go, moving around with their busy lifestyles, being able to upload their art, manage their orders, like fulfill shipping and all of that from application is going to be something that will provide them more utility than just a website. From a technical perspective, there's also a scalability of backend. Their current backend, which we'll get into later, is not potentially as scalable as the new backend which we've implemented. Next, Serge is going to talk to you a little bit about our solution as we planned out this application.
Thank you, Imran. Now that you know about the background of Fields Foundation and our team, I'll be talking about the project solution. So firstly, our vision was to create a software solution to help Fields Foundation in its mission to support BIPOC artists. By establishing a dedicated marketplace, our aim was to provide artists with a platform where they could showcase and sell their artwork to a vast network of fellow creatives and art collectors. The final deliverable is a mobile app that is compatible on both iOS and Android. This app will play a role as a connection between emerging artists who are wanting to shed light on their artwork and building their own community. Next, to have a better understanding of our system architecture, let's look into the development view diagram and know about different interactions and dependencies within our system. So our system includes two different user flows, one for sellers and one for customers, both utilizing REST APIs to send and receive data. So firstly, for the seller workflow, it enables seller with a complete control over their products. As a seller, they can create, update, or delete their product listings, allowing them to manage their inventory efficiently. And next, for the customer workflow, it allows customer for smooth browsing and purchasing experience. As a customer, they can browse through different products listed in the aftermarket app, view detailed description and images, add the product to the cart, and finally check out. Now for the backend side of our system, the aftermarket website currently uses WooCommerce database, which is a WordPress specific database. So for our mobile app, we have implemented Firebase database, ensuring smooth synchronization between these two platforms. And looking ahead, the goal for the next team will be integrating third-party payment integration system and Twilio SMS push notification system. Next, let's look into the backend architecture to know more about our backend solution. Since the aftermarket website currently uses WooCommerce database and the mobile app uses Firebase database, we have developed custom scripts to fetch data from the WooCommerce database and upload it into Firebase database, ensuring smooth synchronization between these two platforms. These scripts handle a wide variety of data sets used by the Fields Foundation website. And finally, to complete our backend solution, the next team will be responsible for scheduling the scripts so that the mobile app is consistently updated with the latest data from the WooCommerce database. And they will also be responsible for writing second set of scripts to enable bi-directional data flow. So lastly, I'll be talking about the tools used throughout our project. So for the framework, we chose React Native as it is a widely used cross-platform framework which allows to build high-performance mobile app for both iOS and Android using a single code base. For database, we are using Firebase as it provides features such as real-time database, authentication, and hosting. For code storage, we are using GitHub as it provides features such as version control, collaboration, and tracking of code changes. For the IDE, we are using Visual Studio Code as it has a range of features such as debugging, version control, and extension support. And lastly, for the simulators, we are using Xcode for iOS testing and debugging, and Android Simulator for Android testing and debugging. Now I'll pass on to Lolita to talk more about the build.
Thank you, Suraj. Next up, I'll be talking about the build process of our application. So generally speaking, we have 2 quarters to be working on the project, which is equivalent to 11 sprints, and we have 2 weeks per sprint. And so what happened was, at first, we were given a Figma file, so like our initial take was just to build our app and focus on the front end stuff and UI stuff. But then after consulting our sponsors, we realized that it's just way much more important and necessary for us to focus on the back end and building the app from the foundation, from the ground. So we decided to switch our scope into focusing more on the back end and building the foundation of the app. So with that little time that I just mentioned, we still managed to accomplish quite a lot of things. And I will be talking about the 5 major milestones that we accomplished throughout the 2 quarters. So the first milestone is the user authentication. So this was one of the very first big step for our application, because this ensures that only authorized users can use and access our content. So users can provide their emails and password to prove their identity, and having this authentication process make sure that we have having this authentication process sets the layer of security to our application, and also allows for various user management as well as access functionalities. The next milestone is dynamic data. So this one marked the beginning and the start of our backend procedure, and it was a huge success. So we successfully populated dynamic products into our customer shop screen, as you guys can see on the big screen right now. So we have dynamic data. So having this dynamic products and data content within our application really enhances its usefulness, provides real lifetime data, and creating a much more engaging and interactive user environment. So the third milestone, as much as we want the backend procedure to last, I personally think it's just way much more interesting to deal with the backend stuff right on the front end. The syncing databases marked the end and the final of our backend procedure due to the time constraint that I just mentioned. We just have 2 quarters. So having this syncing databases with our real data from the dynamic products over there really like assure that we have dynamic data sync in with the databases that we set up from the very beginning of the 2nd quarter, because we already had the Firebase storage and Firebase database set up. So everything was ready to go. The 4th milestone that we accomplished is buying a product workflow. So like, as much as we realized that we ran out of time, so now we're focusing on the front end stuff again, which is like mapping out and gray boxing all of the workflows as much as we possibly can. So this one is one of the example on the customer side. This is the customer cart screen where we mapped out and gray boxed everything with mock data. So the same thing applied for the seller side. This is the seller side order screen where we're like having everything fully mapped out and gray boxed. Next up, I will be talking about the technology blockers and how we solve them. So first, we have the environment dependencies, which is, it happens a lot when we're working on the project because we have the conflicts between iOS and Android, and how we resolve them is we have the README file on GitHub where we're like putting like how we troubleshoot it and what kind of dependencies that you were supposed to install beforehand. So like later on, if someone else also ran into the same issue, they don't have to spend a lot of time trying to figure out what is going on. And then the second one is formatting between iOS and Android. So, you know, like sometimes fonts, colors, and shapes can be a little bit different between them. So how we resolve it is just like make sure that everyone is on the same page before you move on working on the new workflow, like the new screen. And then the third one is the merge conflicts. I personally think this one is a little bit funny to talk about because I feel like every team ran into the same issues because we're working on different branches. It was tedious, but it was fun to resolve it. I personally just do it within VS Code editor. It's super handy and super helpful, but I guess everyone has different ways to resolve it. And then lastly, we have the scripts. So this one, I think it took us a lot of time to realize like to get to know like what is the API call and how to call them and how to write the scripts. We ended up changing our methods a couple of times to make it work. But yeah, so we'll get into the details of the script later. So yeah. And next up, I guess is the most exciting part, our demo. I'll pass it to Andrew.
Thank you. So next is our script demo. So like it was mentioned earlier, we were tasked with syncing our two databases. So Aftermarket's current website uses WooCommerce database, and we ended up using Firebase for our mobile application database. And so we wanted a universal experience where users can go on the website or on our mobile app, and it has the same products and same workflows. And so there's a seamless transition between using either one. And so what we ended up having to do was we created individual scripts for each API call. And so an API call just gets a specific set of data that's on the Aftermarket website. And once we get that data here, we request it, and we basically set it to some variables that we're able to push into our Firebase database. And so here we're looking at our product script. And so the product script basically shows all of the live products on the Aftermarket website. And so what we wanted to do here, each script is basically the same. There's just a little difference, which I'll cover when I get there. But we first read in some authentication from a basic auth text file from somewhere else. This is just for security reasons, so we don't have it laying out on our file. Here we then make the API call to products, passing in that basic auth into the parameters, requesting the data, and then loading it into this products variable here. And so what does that data look like? The data is basically given in this huge long format. It's in JSON format, but basically it's just a huge list of all of the products on the website. And so what we do with that list is we have to loop through it and manually set each individual variable. The reason why we have to do that is it's hard to automate different API calls because each call gets different data sets. Here, products is unique because we actually have another API call within it called products variation that takes in a product ID. And so that just means we have different variations that describe an individual product. Here, we just set it into a product variation list. So that's basically just doing the same process. We're making an API call and then setting all of the variables into a sub list, which then gets put here into the product variation list. Once we've set all those variables, we're able to append it to the end of each product here. And then once all that is done, we're able to create a document here for products. And so that goes to our Firebase database, where it will look like this. So all of the left side here are all of our scripts. So those are all of the specific data sets that we're getting from the Aftermarket website. If we click on products here, it shows documents. And so documents is basically just an individual product. And so if you click on product 700, for example, it's going to show a collection of variables, and these variables just identify a specific product. So you'll have like type, so if it's a painting or clothing, you also have price, size, etc. And once we have all this data, then we're able to dynamically load it into our app to reflect the Aftermarket website, so it looks the exact same. And Imran will show that what it looks like in our next demo.
Yeah, thank you, Andrew. So let's take a look at our aftermarket application. Currently, it's in guest mode. Essentially what this means is you'll still be able to look around the app, purchase products, go through all of that thing, but essentially we're going to walk through what it looks like to log in as a user and sort of use the application from the customer perspective. Authentication is currently only through email, though later there might be Facebook or other platform authentication. You can view products through the home screen or the shop screen. Currently, the shop screen is what we've invested the most time into. So as you take a look at it, just like Andrew mentioned, all of these products are actually being loaded with dynamic data, meaning you can go on the current Aftermarket website and see these very same products as you can here. Once a customer scrolls through these products and finds something they might want to buy, you can click on a product, view its details. You can change the color or adjust the quantity that you might want to buy and either add it to your cart to purchase later or press buy now if all of your information is already saved within the application. Once you decide to buy something, you would navigate to the cart. This is an area where we didn't unfortunately have time to get dynamic data due to time constraints with the project. With that being said, all of the forms for this section are completed. So such as the shipping address form, you can enter your information and have it persist. But with that being said, you won't actually be able to purchase any products as of now. However, with this workflow done, complete with payment, shipping address, and all the other necessary information, as well as the shop screen and authentication, all the major workflows for the customer side are mapped out or have dynamic data integrated. For example, once a customer might get to this screen, they would have all their shipping details and information, and then be able to receive their product. We mentioned that customer side was one of the important things that we focus on. The other is the seller side. If you navigate to the profile screen, you'll be able to switch to seller mode. Once you're switching into seller mode, the app will look a little bit different and the main tabs will change. The first tab that changes is the home tab. This tab changes into the dashboard tab. The dashboard tab essentially houses what orders you have, your current commission that you're due. The next tab would be the storefront tab. The storefront tab is essentially like a profile tab for your store. After that, we have the orders tab where you can view your orders, mark them as shipped. And then finally, we have the products tab. This is where you might view, edit, or update products as a seller. One of the key things that you want to do when becoming a seller on this application. Like we mentioned, one of the key pieces of accessibility is being able to actually manage your shop on the go. And so being able to edit products as well as add them, not just through the computer, but through your phone is what really gives this app an edge. We've also added some other functionality, such as coupons and other things through a drop-down menu, which will appear in a moment. Although, just like for the cart flow, we did manage to get dynamic data mapped out through the entire seller flow. For the most part, we have all of the screens mapped out and able to navigate through. And with Andrew mentioning the database being set up, future teams are actually able to go forward and get through the process. So let's take a look at sort of what might happen going forwards. Okay. What did we learn from this? This was a really big process, spending 3 quarters doing it. And the biggest thing we learned was flexibility. As mentioned several times in this presentation, we went into this process thinking that we would be really focusing on getting data live quickly, getting the front end really beautiful. But as we looked at it more, this transfer of the database resulted in a need for having live data set back and having the new database set up as the priority. This change in priority was really something that we had to take in stride and work with as we decided what would provide the most value to our sponsor. With that being said, as the sponsor is continuing next year at Seattle University, we provided some value by setting up the foundation. Because the databases are synced, all of the data necessary for a future team to complete the application is in the new database. As shown, the app is gray box, meaning that you can navigate through all major workflows and screens. And because of that, dynamic data is ready to add at the important locations so that a future team isn't starting from scratch, but starting with most of the necessary tools there to complete the application. We're going to open the floor to questions after thanking our sponsor for being so willing to meet every week and thanking our advisor, Tim. So any questions?
Probably have time for just 1 or 2 due to technical things at the start. So questions from the audience. So check the Zoom.
I have a question. How are you guys handling login? Like, are you guys doing your own method or are you guys utilizing a third party plugin for that?
Great question. Firebase actually has login and authentication as a feature. So that's one of the reasons why we chose it. It's pretty encompassing and is pretty good for scaling. So authentication along with integration to our database is available to Firebase.
So was that the authentication of logging in, was that one of the main reasons why you guys plan to not use the original database for the app instead of like having 2 sources of data?
That's a great question. The original database was pretty specific to the website, WordPress. On the other hand, this new database offers a lot more options in terms of scaling later on. While it does also provide authentication, one of the big reasons for that shift is because as talking to our sponsors happened, they realized that a new database might actually be the future for both the website and the mobile application. And so starting the transition was something that we realized would provide value to them.
And I believe that's all that we have time for. Let's give a round of applause.
Now we've got, adult communication up next.
Yes. Yeah. There.
Just, let's make sure. Let's just make sure that you show
Oh, the second.
I see.
Yes, that's fine. Okay.
Search. Then I go to.
And it's in the sound. That's what we did for our practice.
Make constant feedback if you're playing.
Hello.
Oh.
Okay, cool. That was fun. Hello, we are teams 2304 and 2305 working with Converge Media to present two different applications, a mobile application and a Roku application. So as for introductions, we have the mobile team up first.
I'm Kalen, I'm the project manager for the mobile team.
I'm Dan Gall, I'm the business analyst for mobile team.
Hi, I'm Sean Lee, and I'm the DevOps and architect for this quarter.
And for the OTT team, I'm Tuan Fan and I'm project manager for this quarter.
I'm Allie Nguyen, and I am the Scrum Master for this quarter.
My name is Anna Perna-Mandalika. I am business analyst and test lead.
I'm Sean. I'm the DevOps for this quarter.
My name is Na. I'm architect. Awesome. So, we also want to really quickly thank our external stakeholders. We have the founder of Converge Media here with us, Omari Salisbury. We also have worked with our sponsor liaison, Ike Everard, and of course, our faculty advisor, James Lavar. Awesome. So let's get into who Converge Media is. So Converge Media is a media content creation company based in Seattle, and they focus on creating content to amplify Black and Brown voices. Their mission is to essentially inform true local news and entertainment focused on communicating authentic representation, promoting local businesses, exploring different community issues, and more. Becoming known during the George Floyd protests a few years ago, providing audio and video commentary from the front lines, the barricades, and the CHOP area. So currently, all of their content is hosted on these third-party websites. Think YouTube, Facebook, and Instagram. Yet these implementations or these systems come with a few limitations. Specifically, in regards to the George Floyd protests, the documentation that came out of that had, when put onto those third-party systems, came with a lot of forced quality compression, suppressed and disabled live streams, or less videos being recommended to viewers, which as a content creation company does matter, can grow audience. So when it comes to growing Converge Media as a platform and expanding their audience, it's a great need to seek independence from depending on these third-party systems, coming to a place where they have their own platform in-house. So with that said, comes with our solutions. So we have the mobile solution and the Roku solution. These two applications commit to expanding the Converge's audience. It also enables for a lot of growth in terms of the company and accessing as many viewers as possible. So with these solutions also come business and financial advantages. You can disregard all of the external suppression that is forced onto that content, while also from a more financial lens, enable advertisement revenue generated from these third-party systems to be reinvested right into the business instead of those third parties taking a cut of that. So with these platforms, with these solutions, it enables a way to connect Converge with their audience, with their content, without any mediation in the middle. So now I'm passing it on to Ali, who will explain our vision and
Yeah, so our vision for this project was just to expand on Converge's mission of, building community and bringing people together across the Pacific Northwest, but specifically providing access with a quality viewing experience of their content. We were able to see our visions through our solutions and our goals, creating both the OTT app and the mobile app. And in the early stages of our app development, while we were discussing kind of the desired features that we created a persona that would fit the description of a Converge Media viewer. In app development, basically a persona refers to a fictional representation of a target user
just to creating a detailed profile on their basic needs, preferences, behaviors, goals. During our development and our design, this process ensures that the app really caters to the intended audience effectively. And so here we are. This is our persona, Jalen Black. This is actually based off someone I'm pretty close to actually in person. But Jalen Black is a barber in Seattle who's not only passionate about cutting hair, but is really passionate about connecting with his community. He is well connected through his community, through his personal relationships, through his clientele of cutting hair, building that connection in person, but also online. He's very active on social media, which he uses to help his business, promote his business, keep up to date with local news and whatnot. And he's motivated by his community and the support that he receives with his connections and his work. During our development, we used Jalen's persona to really prioritize all the critical features for our minimum viable product for both of our teams. And that being said, both of our teams shared very similar milestones. This included an integrated back-end database, as well as the front end, the layout and navigation, and video playback features, and more specifically for the mobile team, the dynamic pages. And I'll pass it on to Sean.
Yeah, all of these are the inconvenience, but the camera only captures the side, so people can come over to the side while talking.
Oh, okay, all right. Okay, so this is our WBS chart or work breakdown structure chart, and this is a condensed version that combines some of the aspects from both teams onto it. So first off, we have initialization, and this shows like stuff that we did before we started working on the project in terms of actual development, what things we needed to do, such as researching and creating our scope document, determining what we need to do for to have a successful final deliverable, and the design doc, which we look at different tools and processes to see which one is best fit for our project. And on our execution, we did things like creating our document database and our Azure Blob storage, as well as our media services, connecting that for our backend, and creating our app server. And on the front end, we've done things like designing our wireframes and then also more specific components that are necessary for our app to function, such as video player, search bar, things like that. And for testing, we plan to do things like development testing, release testing, and user testing. And finally, for our turnover, we're planning to hand over our code base, our presentations files, and our demos, and as well as our account information, so that Converge can access all the things they need to once we're done with this project for now.
So our final deliverables based on these major milestones that we've had, what we have for you today is our integrated backend that specifically the OT team worked on data migration. That basically means, taking their data from their current or what was their current backend to a new database so that we can stream better, basically. And then our front end, which includes the homepage, the show page, film page, about us page, and then when clicking on a thumbnail of either a film or a show comes the detail page with the description, length of video, etc. And last but not least, the video player with the playback features.
All right, so for the mobile side, for the database part, we created the MongoDB database where we have structured data JSON that determines what the file will look like, what the data structure is going to be for both teams. We also set up an API middleware for both teams to get data from the same point. So in the future, if Converge needs to manage content for both OTP and mobile, they will have just one part of access for that. For the app, we have a homepage, a series and video page. We also accept user input and search. We were able to show both series and video details, as well as support video playback. We also allow user input for newsletter sign up, so the Converge can keep track of who is signing up for their newsletter services. We are also able to search for videos based on titles in the app, so that people can find what they like and they can just watch that.
So I would like to share these remarkable tools that empower the OTT team. One such tool is Figma, a collaborative design platform that allows us to create high-fidelity prototypes. In addition to Figma, we rely on the Roku streaming stick. This device serves as a conduit for projecting our channel onto our home TVs, allowing us to test our code and content feed in real time. For the backend side, we harness the power of MongoDB, a NoSQL database. To deliver our content efficiently, we leverage the capabilities of Azure Media Services and Azure Blob Storage. These cloud-based services provide us with the infrastructure to store and deliver converged media assets. Also, we rely on the Visual Studio Code as our integrated development environment. In addition, we utilize programming languages such as BrightScript and SceneGraph. They are both programming frameworks used for developing apps and user interfaces on Roku devices. In conclusion, these tools empower us to create captivating user interfaces, seamless streaming capabilities, robust database management, and efficient development workflows.
For the mobile side, we utilize React Native as our main framework. It helps us develop the app faster because it supports cross-platform, so future teams can add in Android, iOS support for both platform. We also utilize Node.js as our middleware server, so we created our own API server that is currently deployed on Microsoft Azure. Our backend remains the same with OTT since we're just using one backend for both solutions. So utilizing MongoDB in conjunction with Azure Media Service and Blob Storage for a comprehensive backend. We as a team also use Visual Studio Code to work with JavaScript and TypeScript since those are the main languages that React Native and Node.js uses.
Next, I would like to take a moment to illustrate the Roku app process using the sequence diagram, focusing on experience of Jalen. First, our app leverages the capabilities of BrightScript to process users' remote control key presses. Every key pressed by Jalen is visually detected. Once the key press event is detected, the system handles it. The Roku scene graph generates the display components, including video and keyboard elements, which are then sent to the screen for Jalen's viewing pressure. In the event that Jalen wishes to watch a video, BrightScript makes a request for the metadata associated with the video. Also, to ensure smooth playback, BrightScript initiates the streaming process by creating a URL for the video. This URL becomes accessible after the video is stored in an Azure Blob. Finally, the media services streaming endpoint collaborates with Azure Blob Storage to locate the video and stream it on Jalen's Roku device. At this point, Jalen can enjoy the immersive streaming experience.
Right, so here is the sequence diagram where Jalen would want to watch a video on the mobile application. So first, Jalen would open the app and establish a connection. Next, he would be loaded onto the home page. On the home page, there'll be an API call to fetch data from our document database. And once we retrieve the data from document database, there will be a call to our Azure Blob Storage to load all the photo content that we have stored there. After this point, this will look like the app has been fully loaded, so this happens really fast. And so when the app is fully loaded, Jalen can see all the content. He can click on one of the corresponding thumbnails to the videos he wants to watch. So this would take him to the video page where he can watch the video. On load of the video page, there will be another call to our document database to retrieve the contents to display on this page. And then we will get the link to establish our connection to our media service, which Jalen would be able to watch the video in real time. And after he wants to watch the video, he can exit out of the video player and he will return back to the home page.
Right, and then following up on that, when we were developing our backend, we chose MongoDB as our database of choice. MongoDB is a NoSQL server or NoSQL database and features flexible schemas and this allows us to have more, to have faster development and be able to change things on the fly, since we're still new at this, so we might not have the correct schema at the very start, but we can adjust it as on the fly, much easier with a NoSQL type database. And it also features horizontal scaling, which allows Converge Media to have more cost-effective forms of expanding when the time is right with this with these applications. And the files that we're storing there, it's stored as JSON files and it's treated as JSON. And you see me up there as an example for a video file where we have the title, thumbnail, description, and there's the video idea that's covered by the thing up there. But that's an example of the data we're storing on this database right now. And additionally, we developed a Node.js server that we talked about previously. And this Node.js server serves as a middleware for MongoDB and our applications. And some key packages inside of it is Mongoose, which allows us to connect to our database, as well as having application level validation, so that the correct, on the application level, we know what file, what fields in there, and what structure it has. For example, we have the contact info, and we have the validation there, so it knows like if this is a correct phone number string, or if correct email, for that. And additionally, there's Express, which allows us to have REST API for CRUD operations, and we get some wraps down there where we have retrieving videos, such as retrieving all videos or retrieving a specific one, or using a search query to find the videos in question that the user would want. And additionally, we deployed this on Microsoft Azure so that both teams can use this app server.
And here is a little sample snippet of code for how the OTT team is able to access this data as well. Up where you see URL show list shows kind of the main entry point in which this data is fed through. It basically is just the URL. Each of these URLs are for a specific series. So within those URLs have specific episodes and the details that go along with it. And this will be displayed horizontally on the screen as well, if you could see that there are fields for rows and children and whatnot. But you'll see that in our demo.
We will showcase our user-friendly interface of our channel, specially designed to make the navigation more seamlessly and enjoyable. As user open the channel, the homepage will disappear. He can do the remote control and navigation to the page and to the episode of the show he wants to watch. When he navigates to the show page, he can notice overhead at the top will have the small description of specific episode. And when he clicks on the first episode of the True or False, the detail page will appear and provide more detail about the episode. And now we can click on the play button and play the episode.
The truth with proof, the truth with proof. If you nice with the sports, then he's swooping through. He gon' have.
He also can control the play back button, pause the episode when he wants to take a break, or forward the episode to the specifically the scene he wants to
It's
watch.
been years in the making, but I'm here, baby.
And we also provide the About Us page where he can the film page only have one film for him to watch. And About Us page, we also provide the About Us page for him to learn more about the company, and the QR code for him to know more about the details and support our company, and also the social media for him to get engaged and learn more about the latest news or the upcoming episode.
So here's the demo for the mobile application. As you can see right now, this is what was loaded on the home screen, and you can scroll through these different series to see different episodes. See example on the screen right now, we're scrolling through, and for example, if you want to watch an episode from Truth or Proof, we're able to click on the thumbnail, and then the video will load. And we can click the read more to see more description. And then we can also do a full screen.
The truth with proof, the truth with proof. If you nice with the sports, then he's swooping through. He gon' highlight you, and nobody live like us, fly like us. We gon' find you, put the city behind you. Let us know you got skills.
We can close out, the video will pause, and we can play it again. And then so to get back, we have it set so we can swipe to the side. So it will return back to the home screen. And our pages are dynamic, so everything we can click on has accurate data from the database. So we click on this, a new video. And then we'll be able to play. We also go see what is part of a series by clicking on the slider box. And this is where all the episodes will be displayed. We can also click on the title on the homepage, and the same thing will happen. We'll see all the episodes displayed for that series. And so if I wanted to give my information to Converge Media to sign up for a newsletter, we also implemented the newsletter sign up. As you can see here, I am typing in my information. Just give me a second because I was typing pretty slow. But I'm giving bad input for email and phone number, and we made it so it validates, it checks if it's a correct format. Is see the error message said bad email, bad phone number. So we're going to give it a good email with a good ending email address. So for an example, and see if we try again, we have a bad phone number. And so we're going to give a phone number out. This is not my actual phone number. Don't try to call it. And then we can sign up and successfully submitted. So also if another user tried to sign in again for the newsletter, we're going to do Bob Joe. And he tries to give the same email address that I just gave. We have it set up that it checks for duplicates in the database, so it will not let Bob Joe submit for the newsletter. And then you'll see that soon. We're going to type it in, and it says its failure is already in use. So then we're going to just change the email so it's not used. Change some numbers, and then we're going to sign in, and it says successfully submitted. And so one of the last functionality that we implemented was a search page. And how it works is you type in something and it will search all the titles for a letter. See if we typed in D, and this video we clicked on has a D in the and, so it shows up. And then so we can watch the video from here. And read more information about the video. And then we can try some different things, like we're gonna type some words, like we're gonna type freedom. It shows up everything that has freedom in the title. And then we're going to type Converge, and it shows everything that has Converge in the title. And one of the last things we implemented is that logo at the top. You can click on it. Oh, and this is bad search, so it won't show up anything. Click on the logo on the top, and it will return you back to the home page.
So we have learned many lessons after working with teams for the last 9 months. One of the most important things is the teamwork. A single person or even a pair cannot complete a challenging project. That's why we need our teams. And moreover, a clear communication and of expectation and issues like blockers is essential. And we have learned how the tech industry work from the front end to back end. And one of the lessons we find ourselves learning is that things will go wrong, and there will be delays, and tasks will take more time than expected. And this happened to us as we integrate to bug-free module, but things still went wrong. And plan for this is by being realistic of what you can accomplish and allowing for setbacks. And the last thing we want to talk about is the work for the future team is to finish our task from our backlog. The first thing is to secure the database to support the user creation features and storing the user information. and Converge Media and wants a backend website to upload and manage their videos and photos for the apps. And user can also customize their apps to suit their eyes. And moreover, on the OTT side, we want to integrate the search functionality and watch later playlists. And also we want to have the live streaming features in our apps. And for the mobile side, for the mobile side, we want to complete the photo and user profile pages and support the podcast player. And finally, we want to have the comments and likes sections for each video to connect the user with the app. And this is the end of our presentations. To anyone have any questions? Okay.
So I noticed that you're using Azure Blob Storage, but then MongoDB for your structured database. Why not Cosmos DB? Keep it all under one house.
Well, one thing is, I think we're choosing MongoDB because like we're familiar for the first thing, and also the costs were more appropriate for the scale we're at the moment. Yeah.
Yes.
There was an expression that caught my ear at the end. You said bug-free module. Can you explain, elaborate what that means?
Okay, so we have like two separate modules that we assign for two members. That is the video player and the detail page and the video player. But there's a button in the detail page that can generate like a player to stream the video, but the button didn't work out and we had to work around a little bit to make it work.
To elaborate more on that, just speaking for the OTT side, I think during development, what we found was originally like all our pages were working, but with the kind of hierarchy and the screen stacking, we found some bugs. So like, for example, like if you go into the homepage and then you click on the thumbnail and then you exit out of the video and then go to the show page, like there was like overlaying, there was overlays and something wrong with the screen stack. And so with what we currently have, we were able to kind of fix up those bugs is what we were mainly focusing on. Yeah.
Are there any other questions?
Also, is there a question? Okay, I just wanted to say, for the earlier question that Tim asked us about the database situation, we also use specifically Azure's media streaming service. So that is in combination with their blob storage. So that was another reason why we picked the two different ones. So it kind of worked out that we were familiar with the document database, and it worked in our favor that Microsoft has all these pre-built in functionalities that are like Microsoft.
All right, if there aren't any other questions, we would like to thank Omari Salisbury and the Converge Media team for providing us with this invaluable opportunity. We learned a lot and we can only thank you for being here with us for the last 9 months. Also, our advisor, James Opari, for sticking with us, for guiding us, for helping us through the tough times. And also we thank everyone for attending, spending time and watching what we did over the last 9 months. If you'd like to see more, come to the 3rd floor. We have live demos. All right, thank you. Omari, Mr. Omari Black.
I need my photo. I'm so proud of this team right here. You guys, you know, come over here. Let's get a nice picture in here. You know what I'm saying? Echo, come get a picture. I'm so proud of this team. Let me tell you, these guys, since this project started, We've gone through a lot of converge, you know, the central district is our neighborhood. There's been a lot of things that's happened in the central district. These kids have kept working. They never stopped working. And some weeks we couldn't be on the call. We was in crisis ourselves, but they never stopped working. And sometimes they had to make the best decisions for themselves, and their professor was there to guide them, and they never stopped. I'm so proud of y'all. Right there. Now I'm gonna walk to the third floor. Oh, guys.
Whoever's gonna be presenting it should be on HDMI. HDMI. There might be an adapter for something. Yeah. I think, you know.
Yeah. You guys, I want to say.
I'll be up on the top floor. Top floor. Yeah.
Now I'm starting to think I actually put it three after my props. That's it. That's either some of their all these things to their courses or whatever. Because that of course that I teach one where unit testing and testing. Do what I unit testing / code coverage just as a way of validating some of their software. But I wanted to kind of, I don't know, people are not doing this such a good job. Yeah, I mean, we're teaching, so that it's not a testing particular class, so we do teach we do functional coverage, but I think more, I think in this particular class, which I'm kind of following a pattern in other teachers that he's just really big on unit testing code coverage, so I just kind of kept that going. So that's but that's I'm just trying to look at it from academia in general as a way of kind of helping the get an industry what they might need to. These are the QA6 are professional testing. Their audience is black box testers. I'm sure there's some white box people there too. A lot of you, you know, a lot of the black testers.
What I see is.
Well, the audio would be going to share.
Oh, right.
It tests
because the thing I was just sense to test, and of course, no systematic. So.
Yeah. So there. Headset. They're not necessarily, obviously, you can open it any company that you know. You want it, you cannot.
Oh, yeah.
Yeah, so that's kind of like, okay, we're gonna function that, and if there's edge cases, we'll test behind it. So that's not really.
I'm excited.
Oh.
Oh, yeah, this is like, I had to do a job in case. Probably not because of time. Also, I started this. I'll say. That's really that I told you about. Where you have a lot of extra. So my kind of wrap but we do what we do. We have the students for very short period. We're testing. And I do remember you saying way back, using models type of thing. But that was a lot of defect prevention. They need for testing. So that's another area too. Is it's up in academia. We should always decide for it. Burden ourselves with such which there's better practices. With their models, probably don't test they generate.
Let's do settings.
I think that was it. We had this other session 4 years ago, and it's probably similar, isn't it? It's maybe on the bigger ones, but on these type of projects, it's incredibly rare. I mean, we did one other one, but we didn't. I know it's web based, it's kind of simple stuff. And that's the other part of that. We don't. It's hard to resemble real life projects to some extent. Like a project. I mean, it's so much bigger, much more. So we can't.
You might be able to look into, I think very solid. It's like under forms to find additional things and others like videos, but you can also done stuff. So do the cascade.
Yes. At the end of Red, we do have we do have and we may do things to software engineering track. So it's not an emphasized thing. Certain courses might refer to me. And I look at projects, I live outside every class in here. So I want one team. I like those. It's like first impression that I didn't know you were there. So I took that as soon as we did. But I so many. Yeah, how's it going at that? Programming. Yeah. Yeah, I can make it. It's like a famous piece. Oh. Yeah. It's like. I gotta do an interview. I can't show up like.
Yes, it is. And I've tried to interpret it and I still.
This side is like, everyone's on this side.
Testing 1, 2, 3.
Good stuff.
Hello, we are honoring our storytellers, otherwise known as Group CS 2314. Starting from me to the left, I am Matthew Lau. This is Supreet, that's Sarah, and at the far end is Wesley. Our advisor for this and the advisor for the meeting is Braxicona, located to the left, and our sponsor for our group was Yolanda Arton. However, she couldn't make it today, unfortunately, because of a meeting, but we have Mike over here on the right. So thank you, Mike. Our problem statement was, as time goes on, a lot of the history throughout the community was being lost due to gentrification or other things. And because of that, and we wanted to preserve some of it in museums or other such things. And the opportunity we got was learning about the life cycle and development of an immersive experience and communicating with industry professionals. Our project vision was to allow users to interact with objects and learn about their community. And our goal was to allow those in the communities to share their stories.
For our final deliverable, we had a museum with two main exhibits and a lobby. Exhibit 1 was an item gallery with a video player, and the item gallery was different local businesses of the Seattle Central District. And Exhibit 2 was an audio and picture gallery. So when you walk in, there are different pictures of storytellers from the Seattle Central District, with audio telling their story and history of the area. For the logical view diagram, when the user connects through the Oculus using a world connection, they are spawned into the lobby. And from the lobby, they are able to interact with the video that we have in the lobby. And then on the left, they'll have the audio and picture gallery. And on the right, they'll have the item and video gallery. For our key techniques and technology, our primary build was in Unity. So the walls and all the different artifacts that you'll see, such as the floor and ceiling, are done through Unity. For add-ons, so when you play a video, there's a pause and play button, and that is done with C#. That was an add-on feature that we used code to write. We also use Blender to create the signs and different items inside the museum that you can't really just build inside Unity. And then to view and work with our museum, you have to use the Oculus headset. For the build, our major story was divided into smaller stories that were easier to work with. We worked with 10 2-week sprints for the last 2 quarters. And our biggest themes were the 2 exhibits in the lobby. For us, we found blockers to be learning Unity, because none of us really had prior experience with Unity. So there's a bit of a learning curve getting adjusted to that, as well as graphics. There's a lot of different ways that you can implement graphics. So as I talked about before, you can use features that are already in Unity, or you can use Blender and add that in, or you can use C# code to create other features. So trying to figure out what model was best was also a blocker for us as well.
So some of our major milestones was finishing up the research. Throughout the month of January and February, we were working with our sponsor to kind of solidify what we wanted to do. That is where she gave us a list of resources from videos of the businesses, and then a list of different kind of storytellers and elders in the community. And from there, we kind of just went with it and picked out which ones we want to do with the help of our sponsor too. In addition to that, obviously, as we stated, we have a video player. And so when you walk up, you have the ability to hit a button and it'll play the video. And you also have the opportunity to pause the video too whenever you want. In addition to the videos, we also kind of have an audio player, which is overlaid with a photo of our sponsor. So when you hit the button, you can listen to, or not sponsor, but storytellers, you can hit the button and you can have the storytellers tell a story about the community or about themselves. And so it's tied with their photos. In addition to that, our last thing was trying to figure out how to do testing with the Oculus headset, because we've never really messed with Unity or the headset that much. So this was kind of one of our biggest things. We were able to debug and figure out what we need to fix. Next up, we'll have a quick little demo from Wesley.
I'm going to quickly change the screen sharing. So this is our exhibit. This is when you load in, you're in the lobby. On the left is the controls, so left joystick you move, the right joystick you turn left and right. The two triggers, I don't know if you can see it, but I'm like doing a pinching motion. And then the grip buttons is to like grab items. And then the left menu button will open this menu that you can change from continuous turning to snap turning. So continuous turning is like if I'm just turning normally, and then snap turning is I like snap at an angle. I like continuous turn, so I'll use that. So how to grab, I put some instructions on how to grab items and then how to play videos. So you see these like beams coming out of my hand. If I put the beam over it, and then it'll change color whenever I'm in range, and then I'll either click like the corresponding button, like an item would be the one that's on my middle finger, and then for the video, it would be my index finger. So moving into the lobby, we have a trailer from Revere XR's own product. They wanted us to showcase their product as well. So within the lobby, there's this thumbnail and then their logo, and then the video player of the play pause. So if I hit play, they'll play like their trailer for their pause. So then moving over to the right is the businesses. This is our push goal like model. So it would have been like a little robot that could guide you, but since we didn't get to that, we just left this model in as like a little green. So we have Africa Town Center business, we have Black Dot, Infinitely Well, the Fly Blind Guy, it's Art Museum, and then Wanawari. So in front of every business name, there's a nameplate representing them, their video, and then an item. So Africa Town has like technology, so we chose to use a mouse. So if I put the cursor over it and it changes colors, see it turns from like gray to white, and I hit the grip button, it'll fly towards my hand. And see it's in my hand, I can rotate it, and I can extend it, and I can put it back on the table. And so going to the video, go up, hit play. Is the audio?
Yeah, it's playing through the headset, but it's not playing. Try again. It's going through your laptop.
Okay. You point the microphone. Yeah, so if the audio was working, you would be able to hear what he was saying, just explaining what their business is and like their model. So we just have a string of items for each business. We have a mouse, for Black Dot, we have a piggy bank. For Infinitely Well, we have like an incense holder. For the Fly Blind Guy, we chose a spray paint bottle. And for Wanawari, we decided to have a watering can because they have a garden. And I guess you can check it out. You can check out the rest of the experience at our post board. I'm gonna head over to the Storytellers section now. It is kind of a trek, and one of our push goals was to incorporate running, just so that the user can navigate through our experience a little bit quicker. All right, so entering the storytelling exhibit, we have a bunch of pictures of the person we want to represent, their name. So we have Cecil, we have Phyllis, Yolanda, our sponsor, and then we have Stephanie. And on the bottom left of every picture, there is a play pause button representing their story. I'll pick Yolanda because, of course, I have to. All right. Put it.
Yet today, 15 minutes from city, a lot of
Yeah, so you can check out the rest of the other stories if you like later. And that is our demo. I will go back to the PowerPoint.
So after that demo, I will continue talking about some of the major lessons that we learned as a team. We kind of learned that you need to communicate with your team just because there are times where we were struggling with trying to figure something out. So we were kind of like messaging each other and sitting down and talking to each other, being like, hey, like this is what I'm struggling with, like, can you help me? In addition to that, obviously, leads to the second bullet point, which is it's okay to ask for help. And it's okay to like listen to what each person has to say, because a lot of people give out different perspectives on things. And so having multiple perspectives is a lot better than just being single-minded. And then we also learned, obviously, we stated that we never used Blender or Unity before. So we had to learn as we went with the project, and that happens a lot. Sometimes you kind of have to do flexible changes and you have to just go with the flow in a sense. I mean, that goes with life too. And then some of our like final projects and goals and stuff is, like we said, we have a non-playable character, which is a little robot that you guys saw in the lobby. We want to be able to have it kind of interact with the users, to meet them in every single room and give them a little greeting, which is the dialogue part, and having them interact. In addition to that, we couldn't really figure out the roof and the lighting system for Unity, so we just left that out, and that was one of our push goals to figure out at a later time. Like Wesley had stated, we wanted to have the ability to run, because as you guys all saw, it took us quite some time to get from one side of the lobby or one side of the museum to the other side. So by having them run, it allows them to have a better experience and a smoother experience. But the final thing that we want to do with our project is hand it over to Mike over here so he can work on what we want him to do. And so I just wanted to thank you guys all for your support and for being here. And we'll take any questions at this time.
So I noticed that you went with like continuous motion. Why did you choose to do that instead of teleportation?
We decided to use teleportation, or not teleportation, because we felt like it was just, I know we have a couple of areas that are not as immersive as you might think, but I think adding teleportation would have just kind of added to that factor, and then having a second beam come out of your hand is kind of. Any other questions?
I'll say two things first. Excellent job, and really appreciate all the work on this, and I'm excited to take it and keep working with it. And I wanted to find out what did you feel like was the most fun aspect of doing this to you? Any specific thing that stood out?
I think the funnest thing for me was hands down like learning Blender, just because so as a team, I kind of just like, we all talked about having me focus on the modeling stuff. And so I didn't really like Unity that much because I've messed with it before. So it kind of, the 3D aspects of Unity kind of screwed me a little bit. So being able to mess around with the 3D object in Blender was a lot more fun for me to learn and mess around with compared to like learning Unity like they did.
I think for me, I worked a lot on the research during fall quarter with Yolanda, and being able to hear different storytellers and learn more about the Seattle Central District was really interesting to me.
I like building stuff. That was very cool. I guess being able to script some of the interactions between like the headset, so creating like an XR like player and then having them interact with the world is really interesting and fun.
I would say for me, it would mostly just be trial and error since everything was in the dark. So just shooting things and trying to see if they work and seeing if they did was entertaining to say not the least.
Thank you again.
It's only for all of you that you speaking, you have to speak over here. This is that the camera on here.
Yeah.
Yeah. It's very small, very heavy. It's very small right here. So we decided when the next this course. Not this quarter on looking at all. Yes.
Hello, everyone. Thank you for all spending time with us today. Today we'll be sharing our experience working with Cost and our journey this year in creating a virtual reality classroom. So with brief introductions, this is team 2319. My name is Sahil Nunka. I am the architect this quarter.
I'm Greg Gibson. I'm the project manager this quarter.
My name is Akil Kanabudi. I worked in DevOps this quarter.
My name is Jaden Lavala, and I was the Scrum Master this quarter.
Hello, my name is Sean Lee, and I was the DevOps this quarter.
I'm Haley Richardson, and I was the architect for this quarter.
I'm Connor McKenzie, and I was the test lead this quarter.
I'm Kosayar Dinabad, and I was the project manager this quarter.
And I'm Savannah Ton, and I was the Scrum Master this quarter.
And we have our sponsor, Anthony Washington, who unfortunately is not here to join us today, but he is a social emotional learning teacher who works with high school students, particularly in underrepresented communities. And of course, we have Jason Wong over here, who most of you are familiar with. He is our advisor and he's the one responsible for coordinating the project this year. So a brief introduction. So one problem institutions today is that the curriculum and the physical setting is not optimally designed to accommodate all students. Students are placed in individualized education plans, particularly those are the ones with disabilities. And so these students have to fulfill a set of courses to meet their education standard with those plans. And the one issue with these IEPs is that it tends to push away science classes. So the goal here today is that we want to increase access to education to students who are underrepresented with a focus in science. So we want to increase access to that critical avenue of education. And our solution behind this is to create an equitable platform using virtual reality where we can tailor a unique and playful and fun experience for those students that can learn at their own pace. And briefly, some team distinctions. Of course, as large projects, we have 2 teams. So at a high level, our team is 2319, they're 2320. At a high level, our role is to implement the actual lab experiments, and there is to create any supporting tools.
Okay, so our solution is composed of 4 main components. The first one I'm going to go over is the Unity game engine. So the Unity game engine is essentially what houses all of the logic as well as the assets that we built out and sourced for the VR classroom. And we specifically chose Unity over other game engines because it was lightweight. This is important because our target platform for this to run on is the Oculus Quest 2. The Oculus Quest 2 is cost effective in terms of virtual reality devices. It's also an all-in-one system, which means that as soon as we build on the VR app onto the headset, it doesn't need any Wi-Fi or external connection to a computer to work. These are good things, but it's also a lightweight piece of hardware, so it's needed an engine that could work with it and perform well. So these choices kind of informed our next thing, which is the next component, which is Visual Studio. So Visual Studio actually comes stock in Unity. So it's the main IDE in the default. So we just went ahead and used that. Also, we used GitHub for our source control. Okay, so I'm going to break down our project status into a couple of key milestones just based on what we accomplished. I think that the first and most important one to talk about is simply the process of learning Unity. Like a lot of other teams this year, nobody here had a lot of experience with Unity and certainly not Unity VR development. So there was a large part of the beginning of fall quarter and even the start of winter quarter where we just learned Unity and learned the tools that we would be working with. After that, we went into developing the internal and logical architecture of the lab itself. These would be things like physics, chemical laws, stuff like that that we'd have to implement for the target user stories. After that, we went ahead and developed the interface, the user interface for the lab. The user interface is the directions that the user is given in order to help them go through the lab. It's the menus that they interact with to reset the lab if that's necessary. So those are obviously all very important components. After we finished development on that, we started accumulating lab assets. We didn't develop any of the assets ourselves. We actually just sourced them from just a bunch of different places and put them into the lab. These assets would be things like lab tables, beakers, and things like that. After that, we began the data tracking phase. This is essentially a quiz that we have at the end of the lab, which essentially just tests the students' knowledge on what they just did in the lab. The data tracking component comes in where we essentially store the results of the student's performance on that quiz on the headset, so that a teacher can look at them later and understand the student's performance in the lab, whether or not it's within expectations. After that, we just tested the lab sequencing. That's where we as developers use the headset and just kind of go through and test things to make sure that everything is functioning within expectation. So for our architecture diagram, this is kind of a breakdown of the entire system from a relatively high level. On the left here, you see that we start off just with the headset. The headset is actually interacting with navigation that is a part of the XR configuration. Now, XR configuration just allows the just translate the hardware inputs of the headset into readable inputs that the Unity game engine can read and that we can manipulate with scripts. We didn't design the navigation over the interface controller. Those were provided through Unity to us. We did, however, create the VR user interface, which is, again, all the menus and things like that, directions, stuff that helps the user actually get through the lab. In the middle here, we have the game engine itself. The game engine contains all the 3D models and assets, which again, we did not create ourselves. We sourced those. But you see on the bottom here, we have all the C# scripts, and next to that, we have teacher designed user stories. That's because most of what we're actually programming is the logic behind the user stories that that we're getting from the teachers. These user stories are just the specific labs that we're trying to emulate within a VR setting. Now, the two outputs that you see up there are performance data. So the performance data goes to the teachers. Again, this performance data is referring to how the student did on the quiz that we haven't done in the lab. And of course, there's the lab itself, which the student's able to participate in, giving them just an alternative experience to what would be a traditional lab setting.
So the sequence diagram is basically a visual representation of the virtual reality experience. So an actor, in this case, a student, will put on the device, an Oculus headset, which will then allow them to become involved in the science experiment. Performing this experiment would output some performance, and that data will be collected on a spreadsheet, which will then allow a teacher to access that spreadsheet. Going over the spreadsheet, they will then be able to have the opportunity to give feedback to the student. So with the project being ambiguous, we used a Scrum methodology, which helped us structure the project and helped us execute the work, as well as principles to guide us along the project. There was a total of 10 sprints being divided up over the last 2 quarters, that being spring and the current, or winter and the current. And the structure of these sprints were sprint 1 being dedicated to project setup, getting the tech stack set up on the developer's device, making sure it was up and running. Sprint 2 being learning Unity, which was a huge learning curve for us. Sprint 3 basically deciding on a lesson plan. Sprint 4 through 5, which was just the interface development. 5 through 7 being, gathering the assets needed to perform the experiment. And sprint 7 through 10 being the implementation of the lab experiment itself. So throughout the project, we were able to construct many user stories that derive from the 2 presented on the current slide. These 2 basically acted as a baseline for other user stories, as well as tasks within our backlog. These 2 user stories basically being, a student with a disability wanting a virtual classroom so they can learn in an environment that is best suited towards their needs compared to a traditional classroom. and a teacher in a small district wanting a virtual classroom so that education is more accessible and equitable. Having these two user stories, established also helped us, come up with other user stories, such as a student, I want visual instruction so I can perform the lab, or as a teacher, I want labels on the assets so they can be easy to identify. With the help of that, we were then able to, structure our backlog, and within those backlog, we had tasks such as being able to dip a fire stick in a chemical, or being able to interact with objects. What you see on the left, the backlog is carryover tasks that will be documented and passed on to the next group that picks this project up. A lot of those tasks were either save state that allows the user to save the current state they are in, or the experiment being more tailored towards a specific need, and basically a teacher being able to modify their experiment as needed.
So moving on to the challenges. So just to echo what Braden, Jaden, and like the Revere XR team said, this was quite ambiguous territory to embark on, as none of us had any prior experience in developing VR. And so with that being said, there was a significant learning curve. A lot of time in Wind Recorder was allocated towards understanding our tool set, understanding our tech stack, and really just going tutorials and making a lot of learning progress along the way. And there was a large learning curve. Another strong challenge that we were faced with was working with two teams. With this many people, there can be large gaps in communication. There can be lack of clarity in understanding who's doing what, etc. So it's very critical that future capstone teams, when there are sister teams working on the same project, that there is a streamlined communication, more concrete documentation, so that everyone can share the knowledge that we learn along the way. For technical challenges, again, we had to source all the object models, and so we really had to go online and do a lot of research to understand that which models could fit our needs. And then we have to go ahead and implement every single different interaction between those different assets so we can use it for our specific use cases. Another challenge is complicated version control, which is, I'm sure, is a challenge shared by teams, but again, we have a lot of people working on this project, so we have to make sure that people who are developing, the code kind of merges well together. So there can be conflicts in that sense. Another challenge is physical glitches. Sometimes you're holding a beaker, and sometimes you get tilted over to the side, just fall on the floor. Sometimes objects will fall through the floor. It can be sometimes messy, but that just involves doing a lot more research and tackling down into the code to see where these problems may arise. Lastly, it was a large project, so both teams did have to rescope this to be a little bit more feasible. We were quite starry-eyed and ambitious in fall quarter, and so we did have to rescope it and break it down to more bite-sized sort of chunks so that we can accomplish our goals as needed. Another issue with this is that as our team was focused on developing the actual experiment, we did need supporting tools. And so with that being said, I'm going to go ahead and pass it down to Team 20 so they can share their experience, their story with working with Foscos.
All right, so we'll be going over what Team 20 contributed throughout the year and the different things we created. First, going into the start of the winter quarter, we created a basic VR template that labs could be created from, and this involved creating certain core features that any lab would use. And it's included a movement system, of which created two: one active locomotion, where you just move around using a joystick in a constant manner, and then the other form being teleportation via raycasts to certain nodes. We'd have nodes set up where the player would be allowed to teleport to, and then they could point there, and they could be teleported there. We also created interactable objects that would call a script when you touch them. That would be realistic, and then you pick them up, they drop with gravity, and then depending what was attached to them, they might change color, they might light a fire, they might change a chemical, you can do whatever you want with them. And then we also created a player model, of which some of it didn't end up in the final project due to unnecessary complexity, but it's there to hand over to future teams working on this project. And now we're going to the other feature we created, because I created, which Team 14 actually benefited from in their project, which is the video player.
We have also incorporated a media player within the virtual reality environment. And this feature simply involves rendering a video into a rectangular object. However, we dedicated a significant amount of time for enabling the pause and play button for the user interface. And the media player has various use cases and it can be easily integrated into the virtual classroom settings. Whether utilized during the lecture in the classroom or employed as a guiding tool for students conducting the lab experiment. It offers effective meaning of incorporating a video into a virtual classroom experience.
So after kind of working a lot in Unity and starting our initial development, we kind of realized that we had a large need for information, a way to track our users, our students, and information like that. So because we are working with students, there's a lot of information that's really useful for teachers. So we kind of switched gears and we changed from working primarily in Unity, developing this space and implementing other features for Team 19 to take advantage of. And we started working on this database, and this database had a lot of requirements to it because there's a lot of intricacies with it. The main one being we are storing information that is considered sensitive. And so security was a huge, factor for us to think about and maintain. So, another student couldn't necessarily see all of the information about one of their friends and then, spread that. So we created a database, and the goal was to implement this database so that the lab would interact with this database and students could access their information through the lab, and then teachers would be able to view all of their metrics and stuff. So their scores on those final quizzes, their progress that they're making, potentially average time that it takes to complete an objective or something like that. And we ran into a small little problem where we didn't want teachers to necessarily have to put on a VR headset to interact with all of this kind of information that they really need. So we started very late to develop a desktop application where a teacher could log in and see all of this information very quickly, very easily, in a nice, concise way. We had some problems along the way where we were leveraging some infrastructure from the school to build our database and to host our database. And we ran into some problems trying to connect to that database through some code. And it led us to having to abandon all of that work. And it was a really hard time to abandon all of that work. And we had to switch to Azure, which we were already working in.
So as Haley previously mentioned, we're going to be working with a lot of sensitive data, and we also needed some way to make sure that only the teacher is able to view this data, not students seeing each other's students' IEP hours and stuff like that. And we wanted to keep it simple because we did have some compatibility issues. And so by using Azure, we have all the tools in the same place, so they would be able to work well together, and we would not run into as many compatibility issues and needing other third-party softwares, which might increase the cost of our overall project. And with Azure, it has something very handy, which is Azure Active Directory, which helps a lot with authentication and authorization. Therefore, it gives us a little shortcut, allowing us to make sure only the teacher views the student data. And what we designed is we were able to use our previous SQL code by changing it a little bit, by adding that database into our Microsoft Azure, which kind of was a little bit of a plus for us because we didn't have to completely scrap everything from our previous MySQL step. And we also designed, we want to have a single sign-in because for students, rather than having them log into a bunch of different things, having something simple like a 4-digit PIN that would allow them to log into everything and keep up with their progress on the lab is what we were able to accomplish with Microsoft Azure. This is a little diagram on how sort of single sign-on or how we envision single sign-on work. We see the actor, where the student uses the Oculus headset to sort of access our classroom login. And that classroom login would be sent over to Microsoft Azure and their auth server, where they would enter their credentials. And this would allow them to access their progress in the MySQL database, as Team 19 mentioned, which is going to be moved on into the next team's project next year, with making sure that they do not lose progress if they are unable to complete the lab in one day. And after that, they're able to access their student data and make sure that they do not lose progress and can continue on with their lab from where they are.
So by the end of this quarter, we kind of accomplished many things that are a little bit scattered around due to all these changes and scope have to relearn a bunch of new technology as well. So overall, we did, although there are very minute accomplishments, they are very much big milestones for us and also potentially for the future. So the things we kind of created were like database structures, a login system, the video player, player movement and appearance, and also kind of like a small tidbit of like multiplayer. All these little accomplishments kind of like helped, are very small, but help individually as the entire project grows even bigger, to just have a great foundation for future teams to leap off and kind of develop more from. So a lot of these experience like changes and scope reshaping had to with the agile environment actually helped provide us with a more pivoting experience, where our development was able to, with all these 10-week sprints, we were able to shift quickly and make sure our mindset was correctly into our sets. Although it did involve a lot of motivation to happen, and a lot of the things that we changed has kind of impacted us in a way. So we did learn a lot about VR development. As Team 19 has also said, this was one of our first experiences doing VR development. And so by doing this project, we kind of learned a lot about that experience with both front end and back end. So yes, and that's with both of our teams, we created a foundation for this project and for our sponsor. So for next year, a bunch of things will need to be integrated, such as interactability between our database with their classroom, and ensuring that data has been sent correctly, and ensuring that everything is connected and well meshed together, as well as the security in place. But overall, we have created a foundation for the next team to build off of, and hopefully they'll be able to use what research, the time that we took throughout this year, we'll be able to hand it off over to them, and they'll have a much smoother start than us.
Yeah, we're gonna attempt to do a live demonstration now. Just give us a couple of seconds while we set it up. So yeah, we're gonna do, this is gonna be the live demonstration of the actual VR experience, hopefully a little exciting. We can move around, turn around, as you've seen the Revere XR demonstration. We also enabled snap turning interpretation to deal with things like motion, like VR sickness, where like just like people would get a little nauseous when using a VR headset for the first time. But we did disable it for this presentation because it doesn't really stream that well. So as you can see, you can look around, we are in a classroom environment, and in front of us is safety information for the lab. We can start the lab by clicking on it using the pink pointer. And it just gives us brief instructions: take the torch off the table, dip the torch in the chemical, and then repeat. And so I can right here turn the Bunsen burner on. Is a very brief, a very simple fire particle effect. And yeah, I can light the torch on fire, pick things up. You can see that put it on fire is pretty cool. Another thing that we implemented is that in case users drop the torch or any object accidentally, it just respawns it at its original location. And so I'm gonna go over here, pick this up, dip the chemical in. It's now applied to the stick, and I'm going to light on fire again. And look, it's a different color, and it gives more information about the chemical itself, about why it does what it does and what a chemical actually is, and it actually spawns a new one. So I can actually test that out as well. And if I knock this over, it'll just respawn. That's pretty cool. I like this one on fire. This one's more orangey, and another chemical spawns. So I can try that out as well. Dip it in, toss it down, and light on fire. So yeah, that's just the basics right now. Could add more chemicals and stuff like that in the future, more other more training steps. That's the basis of the experiment. I'm just gonna drop this for now. But once you complete it, it'll actually spawn in this end of lab screen. And if you go over here, you can click on it and go through the concept checks as discussed in the presentation. Just a brief, like they'll just record what the students say and print that to a file on the headset so that the teacher will have access to like all the student data. So we can go through, you just click next on what they would like to select. Yeah, and that's the entirety of the lab. We do have another feature over on this side though, where we have a little whiteboard that you can draw on. So that's pretty cool. Yeah. So yeah, that's pretty cool. You can hover the marker itself, you can hover in the air. That's another feature. Instead of like having it drop to the ground, students want to have like array markers, they just like have them hover nearby. But yeah, that's the basics of what we have built so far. And I hope you enjoy it. That's our presentation. Thank you. So does anybody have any questions for us?
Thank you for the excellent project. I think this is a huge problem that you're trying to attempt to solve, like equity and STEM education in some marginalized communities. So this application that you built, the end users were the underserved, underrepresented students, right? So did you get a chance to test this with them?
We did have plans to actually go with our sponsor, Anthony, to try to test it with some actual students. Unfortunately, we never got the actual opportunity to. That it seems like, so hopefully when this project carries over to the next year, they'll have the opportunity to like present a more fleshed out version for some students to test. But yeah, thank you for the question.
And a follow-up is like, how do you think that this kind of technology will help it resource poor countries like Africa, India, all these like third world countries?
That's a great question. I think a lot of what limits those countries like education systems is the lack of resources. They don't have access to like all lab equipment that like more advanced schools do. They don't have access to a lot of like the educated resources like textbooks and things like that. What the Oculus does is it kind of acts as a all-in-one tool that students can use to access all those materials. They don't need physical lab equipment when they have the virtual ones and can perform those experiments virtually. They don't need the textbooks, they have access to those like physical quote unquote copies in virtual reality. And it's also kind of an advantage in a sense because there's some things you could do in VR, as we demonstrated, that you can't do in real life. Like having students play with fire is not really ideal in a classroom setting. And so it's kind of an advantage in that way. Thank you. Are there any other questions? Yeah, go ahead.
So question for both teams, both of you described spending a lot of time climbing learning curves in multiple areas. And that the effect of that seemed to be that the amount of time you spent climbing the learning curve versus doing work on the project, the ratio is pretty high on the climbing the learning curve side. So question is, for future teams that follow on, did you learn anything that would shorten that learning curve, or do you think it would be kind of the same for a future team?
Yeah, that's a great question.
Better defined scopes at the beginning would have helped that a lot. It's a lot easier said than done. We would have liked to, that we could. But basically, all of us learned Media from the start, and then only one team did most data development from the start. We were all working on that. We all spent a lot of time learning it. Then half of us switched off of it. Learning how to work in MySQL and then Azure, which took a lot of time. We started from the beginning, know that there would be at the end of the quarter, at the end of the year, a lot of that learning time would have been cut down. But it's hard to do.
Yeah, that was a great question. Okay.
Yeah, to kind of like echo kind of what Connor said, it's there's a lot of like ambiguity with the scope of the project in the beginning of the quarter. Just because like this was kind of a fever dream. Like Anthony, our sponsor, was like, I don't know if this can happen. I don't know if this tool is actually going to be used, or if it is something that like we really should be focusing on. And so we didn't really have a lot of guidelines at all. So, you know, kind of like understanding all of the aspects that go into the development of something like this, it would have been huge to have at the beginning. And you know, having gone all like through this development process and being able to hand over this all like information to the next team and be like, hey, you know, yes, VR is really cool. The Unity development is really cool and it's really fun, but there's a lot of other stuff that needs to go into the project besides just creating that virtual reality space. I mean, all of us on, you know, Team 20, we didn't think that we were going to be writing database code or, you know, working with OAuth and, you know, stuff like that. Like, so yeah, just even being able to tell them, hey, there is a back end to this and it's really important. Don't underestimate it, is going to be huge for them, I think.
Thank you.
I guess I got a question about the database situation, so I'm a little confused with that one slide. So are you guys only using Azure now, or you have using both Azure and MySQL, or what's?
So yeah, we are not using MySQL anymore. Kind of to go a little bit more into that, because this was kind of a proof of concept project, we wanted to keep costs as low as possible. So, you know, knowing that Seattle U has a database server was very appealing to us because it was free. And we'd already, you know, all of us had taken a database course. We'd all written code in MySQL. So we were all pretty familiar with it. So we, you know, kind of jumped on the opportunity to do that. And the hurdle kind of came in when we were trying to connect our C# code to the database. And I spent, you know, probably 5 weeks working on trying to get that to work. I was all over Google. I was all over staff at SU to see if I could figure out anything, and it just wasn't working. So we decided that it would be easier to just use Azure because we already had Active Directory kind of going. So yeah, we're no longer using MySQL.
And a follow-up question. So specifically within Azure, what kind of storage are you guys using? Like blob, or is it something different?
I'm pretty sure it's like Azure SQL, being an entity relationship database, so very relational, very tight relationships. Any other questions? Cool, thank you guys.